Hello.
Hey, how's it going?
Good. Well, that's a very professional setup there.
Part plural site.
All right. Okay. Great.
Everything all right then?
Good. Yeah. Just flat out at the moment. How are you?
Yeah, good. Been a busy day today between one thing and another. I gave my first talk at NBC earlier,
Oh
so
dear.
that was most of the morning taken up worrying about that talk, and then watching a few other talks and meetings with people, and then this talk again. So 2 talks in a day.
What are you doing the talk again? On?
.NET 5 with the Raspberry Pi.
Oh, nice. Very good.
So I'm just getting stuff set up to be able to do that.
Yeah, I was going to squeeze in my Meadow
Oh, nice.
with gRPC, but there's definitely no time for that.
Fair. Yeah, that Meadows. I've not even bought one and played with it, but yeah, I mean it's .NET Standard on there, isn't it? I think so.
Yeah, that's why I got it.
Yeah, it's pretty cool.
Yeah, I think it came from America.
Yeah. There's quite a few places, isn't there, you can get it from, but yeah, cool. I had a friend who uses one of them quite a lot. I'm hoping that they'll bring us some form of .NET for that new Raspberry Pi Pico as well. That'd be pretty cool.
Yeah. Okay. Hi, Mark.
Evening.
I'm glad everyone got the link. I accidentally sent out a new Zoom link. I didn't realize John posted a Zoom link already.
I didn't see that one. I just went on the meetup page and used that.
Nice one. Yeah. I did update that one now. So how's NDC working then these days? Is it all over Zoom?
Virtually, yeah. They use WebEx, Cisco WebEx, and it's not bad actually. If I have to say, it's better than Teams. Sorry, that's not hard, but it's not as good as Zoom. But it's not bad. Not really. It's it works quite nicely.
What platform is that?
Cisco WebEx. So yeah, it's not massively popular, but it's quite good. Just getting my kit in shape here. There's Mr. Staveley of the Raspberry Pi Staveleys.
Hey, Liam.
Evening all.
Wow, it's been a while since we had a lead sharp, huh? When was the last lead sharp? Was it in November?
The last in person.
Yeah.
November, huh? I'll miss out.
I've not had so like much pizza since like a year.
I know.
So, actually, I think I've had one Papa John's and a Domino's for the last year, when I usually have like at least 3 or 4 months.
So have we decided a running order yet?
I'm easy. Mine's going to be crap anyway.
No, it won't.
We'll get it over and done with.
I'll definitely have that first then.
I think that's first on the meeting site as well.
If it's crap, you put it on at the end, and then if people leave, it doesn't matter. But I can't imagine it's going to be crap. It's going to be awesome.
No, I'm thinking first, and then that way people won't remember by the end.
Have you actually been using gRPC or anything?
Yeah, I've just done a deep dive into it. Basically, I haven't used it in production or anything. I've been playing around with the meadow, and thought it might be a good use case for it. But I don't think we'll have time for that today.
Well, if people are hanging around at the end, you can absolutely show us, can't you?
We're finding with gRPC that it didn't work under iOS or on web apps. Yeah, but that was 2 or 3 months ago when we were playing around with it.
No, they brought something out called gRPC Web, I think, which, but that's not the same. No,
that's for the browser connecting back to gRPC. Yeah, it requires. I was saying it required that wasn't supported at the time, but
it's because of HTTP2, isn't it? Because of there's still HTTP1 flying around. And
the web app supported HTTP2. There was another part of the protocol which it was required, which wasn't supported. But they were looking at fixing it, but I haven't gone back and revisited it since.
Right. Well, you probably know more than me.
So Matt, as your host, you said you were going to host. So do you know enough about everyone to do introductions and stuff?
No. Why don't you do that as the co-host?
Well, I don't know everyone, particularly John. I don't know.
No, we've not met before. No.
Yeah. But you're in Shahid's group, aren't you?
No, not really. No. So I'm actually down on the south coast here in Southampton. But Shahid posted up just before Christmas, I think, about his lightning talks. So then I attended his, and then that kind of led on to being somebody messaged me saying that would I speak here? So yeah.
Okay.
Well, thanks for that.
So John from Southampton, Gopal, you're in.
Right. So I'm in India.
You're in India. Okay.
Yes.
So it Leeds International.
Yes, it's quite past midnight here now.
Oh.
Well done. Very good.
Yeah.
That's dedication for you. Is it Bangalore you're in?
It is Bangalore, yes.
Yeah.
That's
Wow.
Right.
Thank you very much for that.
Yeah. Thank you for
Thank
coming.
you for having
But
me.
we'll definitely get you a pizza next time you're at Leeds Sharp.
Yes, sure. I look forward to that.
Before the lockdown, I was in Leeds quite a lot because I work for Pure Gym and their head office is in Leeds. So I was kind of up there quite regularly, a couple of times a year. So hopefully when everything's back over, I might end up back up there.
Cool. Yeah, I do have to say I missed the meetups in the pub afterwards, and the chat.
The beer.
Yeah, as well. Yeah.
Also, we missed the beer. Yeah. Who knows? By summer, could be a different world.
Yeah, worse probably.
You think so?
Well, I've
So
got
optimistic.
there's a company in Wetherby called Avacta who are in the process of bringing out a highly accurate AFIMA-based test coupled with a mobile phone app that would give you sort of like a COVID passport, and that has the potential of maybe opening up the economy again, at least, pubs and flights and the rest. So I don't think the virus is going to go away anytime soon, but maybe if we have these tests, at least some people could, walk around and go shopping again.
I heard if you fly to China, they'll swab your bum.
Yeah, I've seen that today. Yeah, well, that Dr. John that I watched, he was talking about that. Detecting the virus I don't know, many, many days after you've stopped testing positive in other parts of your body.
Oh dear.
To think
That sounds lovely. I missed that one.
You didn't miss much. I think one of the issues with the vaccine, of course, is that you can possibly still spread it after you've had the vaccine, which is bad. But you're right about the testing. If you can test and prove that people haven't got it, but then with what Kevin's just mentioned there about the fact that perhaps that testing protocol might be a little bit different to what you'd expect.
Yeah, you can't come into Costa unless you swab your bum. So
Well, this is it. It's a through the post 10 minutes test that doesn't require sticking anything up your nose. So
Yeah.
it sounds quite promising. I've got shares in them anyway. We'll see how it goes.
Oh, happy days. Yeah, could be a gazillionaire after this then. So what was the running order again then? Where did we get to? You were going to go first, were you, Matt?
Yeah, I might as well go first.
Matt's firstly awesome. Awesomely first. Yeah, apologies for cutting short everyone to 10 minutes, but we were a bit oversubscribed. We were going to be 15 minutes to start with. But don't worry, Kevin's going to talk really quickly and finish on time, so there won't be any issues.
I'm gonna talk really quickly as well.
I had to cut mine down quite a lot, but there's still quite a lot in it.
Look, I was working on 10 minutes, so I've cut mine down as well.
Yeah.
I've actually never presented over Zoom, so how's it going to work? Do I pass over? Do I make someone else? Do I make the speaker a host?
Whoever's the host at the moment needs to enable screen sharing because it's currently disabled by the host.
Yeah, that's me. Yeah, got it. Yeah.
So.
And then,
yeah,
so I don't need to make anyone host, right? It's just
Nope.
you just share the screen, right?
Yep.
Yeah,
Correct.
it should work. Yes.
Yeah, I mean, and in a normal meetup where there's only the one speaker, I make that speaker a co-host and I turn off screen sharing for everybody in case you get Zoom bombed and then at least no one else can share. But
Yeah.
that's a pain in the bum to do when you've got 10 speakers or whatever. So yeah, do it that exactly like that has just been said.
All right. Well, let's keep it like that then.
Mm-hmm.
Okay, so Matt's going first. Who's on after Matt?
What time is? I don't mind going on after that. That's fine.
Okay.
You want to come on after me, don't you, John?
Oh, I definitely do want to come after you, Peter. Yeah, my talk sort of lines nicely up.
Yep. Segue.
I could just do that after Pete then, seeing as my name's after Pete on the actual meetup page. So
Oh no, John wants to come after me, I think, don't you, John? Is that what you said?
I do, yes.
straight after. Okay.
Yeah. And then
It
you can
makes
come after
sense.
John then, Kev.
Yeah. Okay. That's cool.
So what we got? Me, Pete, John.
Me, Kevin.
All right. Kevin.
I think we should have Gopal next because he probably needs to get to bed at some point.
Yeah, maybe you should go first.
Yeah, that's a
You
good
go
call.
first?
yeah.
No, it's okay. I'll stay awake for all the talks.
Hardcore.
Right, so someone needs to volunteer to go then.
Yeah, I'll
after
go
Kevin.
then.
Right, John's after Kevin. Cool.
John. Right, let me get.
I'm going to pick someone unless you volunteer.
I can go. I can go to that.
Simon.
Okay, Gopal. Yeah. And that means Simon's last. Save the best for last.
Cool. Yeah, if we run out of time, my talk is highly unimportant. So
Oh,
if it goes over, you can always cut me.
I doubt
So
that.
me, Pete, John Staveley, Kevin. Kev.
Yeah.
Yeah. John, Gopal, Simon.
Cool.
Okay.
Wicked. And what time are we kicking off?
So I'm squeezing mine into a 3-minute space then. Awesome. Love it.
I think we go at like 2 minutes past 7.
Speed
something
talk
like that. Give people time to arrive.
Oh, we having a break in the middle, or just going straight through?
Could have a break, yeah.
Okay. Anyone do anything interesting with .NET 5 yet? Anyone got anything in production, or is it a bit early?
Yeah, we're building a greenfield e-commerce website on .NET 5. Not
Very
much
good.
difference. Not much difference really to core. You know,
Faster.
faster. Yeah. But it feels good. Certainly feels good.
Stable. I've not had many problems with it.
Uh-huh.
So I'm not doing any production, mind you, but
I've just had problems with the EF Core 5 stuff, and that's about it, really. And it's just because they've like chopped bits out of it and just thrown exceptions where things weren't fully supported.
Right. Not implemented exception.
Yeah, we don't want you to do this, so we're just going to throw an exception here instead.
Thanks.
Bob needs to implement this exception.
Yeah. How many MVPs have we got on this call?
Kevin and yourself, I think.
Okay, cool. Become an
And
MVP. Cool.
Simon is a first-time speaker, so well done, Simon.
Awesome. We definitely do not want to chop you out at the end then. We need to give first-time speakers a platform wherever we can.
Yeah.
I hear the sound of my own voice more than enough.
We haven't, though. That's the point.
Yeah, always looking for new speakers. So if any of you got any ideas for a talk you'd like to do or thinking about doing, come and approach myself or Matt or even Kevin. Kevin runs 2.NET meetups. So
and me.
And Peter.
Yeah, always welcome to fair.
Is this a monthly talk or some periodic?
It is monthly. Yeah, it's been sporadic during lockdown.
Okay.
But usually, yeah, monthly. Apart from
So
December.
Usually it would be in person, I think.
Yeah.
Yeah.
In person,
Right.
down the pub,
Right.
with pizza.
Yeah.
Okay.
That's the best part, really. You're muted, John.
Being on the South Coast, there's only a couple of groups down here. So being virtual, I've managed to attend a lot more.
Yeah.
To be fair, it's made running like 2 groups easier because I run 2 groups
Yeah.
in different cities. So,
Yeah, it definitely has some benefits, isn't it? There's like talks in Liverpool that I attended, I would never have attended otherwise. Saves a lot on traveling.
I do feel like they need to be like shorter though. So I've been to quite a few which have been like 3 hours long, and they get a bit of a drag after about an hour. So they're quite hard to kind of concentrate. Yeah,
we sent out a survey to the .NET Knots people, and that was what came back. 2 shorter talks works well. So if you can have a longer meetup, 2 40-minute talks or even half an hour talks was what was preferred. So we've done that for .NET Knots. Knots IoT is a bit different because it doesn't tend to be hardcore very often. Whereas with the .NET meetup at .NET Knots, Knots IoT is not as bad. .NET Knots, you can end up with some really hardcore, deep topics, and they're awesome and I love them. But if you have 2 of them back to back, people can get quite tired afterwards. And it's not the fault of the speaker, it's not the fault of the content, it's just Zoom, basically Zoom lethargy. It's 2 minutes past 7.
Yeah, should we make a start?
Shall we?
So, well done for everyone for coming. We've got some great talks tonight. Got Matt, gRPC, why, what, when, how. At least 3 IoT talks. C# and Raspberry Pi by Pete. Myself, bird spotting on a Raspberry Pi with Azure IoT Hub, etc. And then John, OAuth Flow for IoT. Kevin sticking rigidly to 10 minutes, testing like a human. And then Gopal calling in from Bangalore. Well done, Gopal, on Azure AD B2C. And then a first-time speaker, Simon Shinkins, the Mediator pattern. So well done, everyone, for coming. Thanks to Fruition IT for sponsoring the event, despite being in lockdown. That's really appreciated.
Happy to do it, and yeah, always happy to be a part of the community. Cheers, John.
Great, let's kick off then with me. Right, so my name is Matt Ross. I'm a .NET developer. I'm the co-founder of Leeds Sharp, and I'm going to give you a very quick overview of gRPC. So what is gRPC? It's straight from the website, grpc.io, if you want to know more about it, and I'm sure you will after this talk. It's a high-performance, open-source, universal RPC framework. It was developed and is used by Google and was open-sourced in 2015. RPC stands for Remote Procedure Call, which is basically a piece of code that executes a procedure on a different box, typically over a shared network, and it's executed as if it was a local method. Just as a little refresh. It's very useful in a distributed API architecture. Now, you're probably thinking, great, microservices, let's get going. But you might be surprised that RPC has been around since the 1970s and got more practical implementations in the 1980s. And then with the advent of object-oriented programming, we got we got something called remote method invocation with the likes of COM and DCOM and Java RMI. Then the internet became popular, and with it, we moved to REST and SOAP in the noughties. And more recently, we've been tinkering with GraphQL and gRPC. gRPC is a request response protocol, which basically is a client sends a request to a server, and the server sends a response back. That's it in a nutshell. So the big question that always comes up with gRPC, well, we've got REST, why do we need gRPC? So the differences are, it's all about how we serialize our messages, right? So REST is typically JSON, i.e. text serialization. gRPC is binary. REST is a one-directional request, whereas gRPC can be uni and bidirectional, which gives you the ability to stream. Now you can augment REST with SignalR that offers multicasting, but that's not the same as bidirectional streaming. As a result of the binary serialization, the payload is a lot smaller, and unlike REST, gRPC is contract-based through something called protocol buffers, which I'll get onto shortly, and that gives you a very simple way of defining your service and your request and response messages. It works across languages and platforms, so it's language neutral. So that means that you can have a .NET Core client that calls a Python method on another server. It's secure by default, so it's based on HTTP2, and each language provides an API to load gRPC with the required certificates and provides encryption capabilities out of the box. You get authentication via something called interceptors. So you might be thinking, is this the death of REST? Not quite. So HTTP2 is not supported by all browsers yet. So if you have CRUD operations, that's typically REST is still a good fit for that. And because contracts are required, most web apps are not designed for that. Basically, it means that every time you make a change, you need to change the handshaking of the client server. So just as a refresh, this is a typical REST request. So you've got your verb, your post to an endpoint. You can see the protocol is HTTP1. got some authentication, and then you've got a text-based, JSON-based payload, and you get a text-based response back. So just as a nice comparison, again, REST is text-based, slower and bigger, whereas protocol buffers are smaller and faster. HTTP1 has been around for a lot longer, since 1997, and has a higher latency than HTTP2, which is fairly new, 2015. REST is a client server request only, whereas you get bidirectional and async with gRPC. Yeah, like I said, REST is good for CRUD, whereas gRPC you tend to have, you know, more freedom when you design your API. Another thing that you get out of the box with protocol buffers is code generation. We'll look at that when I dive into the code. You do get Swagger with REST, but it's generally considered a second-class citizen. And so gRPC does the plumbing for us, whereas REST you have to write the plumbing yourself. So what are protocol buffers, or protobufs in short? Well, you can see an example on the right, which we'll have a closer look at when I get Visual Studio up. It's an interface definition language. So you define the service, the service name and the endpoints, and you just define the messages, the request and response messages, i.e. the data, in protobufs, and automatically the code gets
and it's a week between visits, so like
generated. Was that a question, or was that just a bomb? It's, like I said, it's language independent. Java has a pure implementation of protocol buffers. So has Go and C, and then C++, Python, Ruby, Objective-C, PHP, and C# are all based on the C implementation of protocol buffers. The advantages are because of the binary serialization, it's less CPU intensive. So for the IoT guys in the room, that would be a good fit. Especially the decoding part is a lot faster. Inferring types is a lot faster because of the protocol buffers, and it has a smaller payload compared to JSON, and therefore saves network bandwidth, and is just generally faster and more efficient. It also scales quite well. The servers, gRPC servers, are async by default, and the clients can be synchronous or asynchronous. Let you decide on that. The clients have also got something called client-side load balancing. So if you've got multiple server instances, the client deals with that. If you need any proof of the scalability and performance, here's a nice stat. Google has 10 billion gRPC requests per second being made internally. So that's that. So here's a little comparison of the payload in JSON. This little message has 55 bytes, the same in the protocol buffers, serialized in a binary format, has 20 bytes. Someone's gone and done a proper benchmark performance test, and you can follow that link there, and found that gRPC is 25 times more performant than REST APIs. So where would you use gRPC? Well, obviously microservices is a good fit. Generally speaking, server to server is great. gRPC is being described as the magic glue between microservices. that includes container to container or IoT devices. But you should try and match the communication to the technology. So like I've said on the previous slide, if web apps, CRUD-based web apps, REST is still a good fit. If you're working with large data sets, then you would look at GraphQL. And if you're after bidirectional streaming, then gRPC is the fit for you. gRPC is used by Netflix and Cisco and obviously Google. And then if I've got time, I'd like to just quickly show you how you fire up a gRPC project. Let me just share the whole screen. Right, so if you go create new project and you search for gRPC, you will see a gRPC service that will give you a gRPC server. The convention is to put the protobuffer interface definitions in a folder called protos, although you don't need that. Quick look at that. Very simple. You define the service and the message, request and response. The number one here is the ordinal position. It's not assigning a one there. It's very important. And then if you save that under the hood, if you go to show all files, not that you would ever need that. I think it's in here.
I don't know if you might need to zoom in a little bit.
Oh, sorry. Yeah, I've got a widescreen. Someone else mentioned earlier on that it's a bit. How do I zoom in again? I always forget that.
Windows key and plus and minus.
What's
Control
that?
and scroll.
Control plus.
Control plus.
Does that work in VS?
No, but Windows key and plus, we'll just use the Windows zoom.
That'll work.
It should work.
Hey, nice one.
Yeah.
Yeah, pro.
Okay. So where is this again? Can't find it. It was somewhere here, was it? Somewhere here is the class. I think if I just go to greeter service and do a control. Anyway, you somewhere in there is the auto-generated code, and what you get is a service. I'm gonna have to zoom out again here. How do I zoom out? There you go. And if you hit F5, which I've already done, you get a service. Then you need to go and fire up a new client, which is effectively just a console app. You stick your proto buff in here and you call this app, and then with any luck I'll type in that and that sends back a message from there. Not much to show, but that's how easy it is to get up and running in Visual Studio with gRPC. And I think I'm out of time. 15 minutes.
Thank you, Matt. Because we've got so many speakers tonight, we've had to cut it short, but we do want to continue the conversation. So please feel to fire any questions you have on the chat. Peter, you're up next. So you want to get yourself lined up?
And you're still muted, Pete.
There we go. Can you see my slides?
Yep.
Good. Right. So I'm going to speed through this. This is actually part of a far bigger talk about a robot arm, driving a robot arm with .NET. So I'll cut short to that, but I can show you that when we get time later if we get time. So just a tiny little bit about me, but I won't spend long on that. But I'm a freelance software engineer concentrating mainly in the IoT space. And also a Pluralsight author and an Azure MVP, and yeah, many other words on there, but I just like IoT really. We'll have a quick look at .NET 5, what that is, and then how you install that on the Raspberry Pi. And then we'll do a hello world or a couple of hello worlds. And then we'll look at the Raspberry Pi GPIO in the circuit. And then we'll look at how we actually control that GPIO, and I'll briefly call out device bindings, which is for doing things like driving servos amongst others. And then some Q&A if we get some time. So .NET 5, if you don't know, allows you to be able to target pretty much any platform you like now, from desktop, mobile, gaming, AI, and IoT, luckily for us. It's open source and cross-platform, and it will run on our Pi, which is great. We get nice new C# language features like records and init-only properties, where you go from something like that down to a couple of lines. Pattern matching on types, which is cool. Top-level programs where you'd normally have hello world at 5 or 6 lines that you can do in 2 lines, which is great for demos and education. And new features like the new system.text.json, which is making people like James Newton King a bit sad for not using his NuGet package anymore. Installing .NET 5 is normally quite difficult on a Pi. There's no apt-get for a Pi. So you'd normally be in editing .bashrc files and things along that line. And if you're not 100% au fait with how Linux works or feel confident doing it, then it can be a little bit perplexing. So I've made a single line script that you can run. And I'm pretty sure that I've got John Staveley, who's on Next, may have run this script to get .NET Core or .NET 5 installed. There's a similar one for .NET Core. You just run that one line there, and then you can see from that GIF that it just goes through and installs everything you need. You just reboot the Pi at the end of it, and you've got .NET 5 installed. So it just makes that whole job a lot easier. So we'll have a couple of demos. First demo, this is what I've got. This is the kit that I've got here. So as I say, normally this talk would involve the robot arm that you can see, but I'll cut short of the cool part, and you can check that talk out later. But what I've got down here is a circuit with an LED, a resistor, and a button on it, and I'll show you that in a bit more detail next. But once you've got .NET installed, then you'll be able to do a .NET --info, and then that'll tell you that you've got version 5 of the .NET SDK installed, and you should be ready to go at that point. But the first thing you want to do is spin up Hello World, and I've already made that call. So from the command line, you can do .NET new console, and you'll get a Hello World program like this. I've got a shared Samba share on the Pi to do all of this. So I'll be running the code directly on the Pi. I don't recommend you do that in any form of development lifecycle. You'd do it on the PC and ship it down to the Pi to run it and debug it. But for the demonstration purposes, I think it's fine to do it like this. So I've spun that up, and I'm already in that directory. And so I could do .NET run from that directory. And I'm running this on a Raspberry Pi 4. So it's capable, it's good. It's not going to be as fast as your multi-core flashy PC, but it will spin up a Hello World and relatively rudimentary applications quite quickly. And what we've done there is just proven that we've got .NET 5 installed properly, which we're now able to build and run that. So it's a good test to do, because I've seen it. People have reported it to me before where they've installed it and they've not rebooted and some stuff doesn't work. So it's good to just make sure that that works. Moving on a little bit, obviously the thing we're going to want to do with the Raspberry Pi is control the GPIO. In case you don't know, GPIO stands for General Purpose Input Output, and it's for driving things like LEDs and reading things like buttons, but it also does things like serial ports, I2C and SPI, and then further things like PWM, pulse width modulation, and that's what we use to drive robotics, servos and things like that. To do that in .NET, we use a system.Device.gpio library, and we can just literally add that as a package, and then we've got control over the GPIO on the Pi. It also supports a BeagleBoard and Hummingbird and Odroid, but I'm a Raspberry Pi guy. I don't tend to use those other boards. It does support Windows 10 IoT. Some of you might have heard of that. There's no real need to use Windows 10 IoT anymore. With the fact you can run .NET and .NET 5 on the Pi, and then with platforms like the Uno platform coming out that allow you to create UWP-based, XAML-based GUI applications for the Pi, then Windows 10 IoT has really had its day. You can install this just with the CLI, as I've said, with .NET Add Package, or if you wanted to use Visual Studio, then you can use the package manager in that, but it's a bit of overkill that would be for for what we want to do. So the GPIO on the Pi, there's a bunch of pins along the side, and that's where the GPIO is. And when you look in a bit more detail, you can see here that each have got a different function. So some of them have got transmit and receive, and some of them have got PWM and power and things like that, and basic IO. And they're numbered. Each of these pins is numbered, and there's two different numbering schemes. The first is the board numbering scheme, and that works with that square pin that's yellow or orange or brown or whatever it comes out on your monitor. That's pin 1. And adjacent to that is pin 2. And then we have 3 and 4 under that, and so on. There is another numbering scheme called the BCM numbering scheme, and that's referring to the BCM chip on the Pi. I don't recommend you use that numbering scheme because now you're having to convert from BCM to pin numbering scheme. Well, just stick with pin numbering. It's going to be easier unless there's a really good reason. The circuit that I called out there before, so we've got an LED, a resistor, and a button, and this is the tech you'll use for Hello World. This is IoT's Hello World. So we've got on pin 10, I've got one side of a resistor, and then that connects through to an LED and then back down to ground. We need the resistor because otherwise we're going to pull too much current out of that pin and we can damage the Pi. It's not the best thing you can do. And then on pin 26, we've got a button. And this is going to allow us to exercise the GPIO and just make sure that we've got full control. So let's make sure we can do that. I'm not going to do any coding. One, it's a lightning talk, but B, I'm going to save that for Twitch, and you don't want to watch me try and find a semicolon that I've missed. So all of this code's available on GitHub, and I've split it all into branches. So I can flick to the Flash LEDs branch and then wait for that to just update itself. And in the CS proj file, you can see now we've brought in ystem.Device.gpio. And in the program at the top, I've got a couple of extra usings, the system.device.gpio, obviously. And I've also brought in threading because I'm going to turn an LED on and off and on and off. And so I want a delay in between that. Otherwise, it's going to be too fast. We won't be able to see it working. In the main, so I mean, this program is going to be quite straightforward. Not going to be much to it. I always leave in this console.writeline at the top. Because if you imagine if this program just read a button and did nothing else, I wouldn't know it was running. So I'll leave something in the console. It doesn't need to be Hello World, but you know, it was there already. I left it there. Next, we can create this controller object here, and we pass in that pin numbering scheme of board. And this section here, this particular object is going to be doing all the heavy lifting of what we're doing in these demos. This is the control we need for the GPIO. Next, we're creating a couple of variables. We've got that pin number variable, and if you remember, we had the LED on pin 10. And beneath that, we've got a light time, and we're going to use that for our thread.sleep. So that's 300 milliseconds. Next up, we just open that pin, and we open it. We pass in the pin number 10, and we open it as an output because we're going to drive the LED with it. And then in a while loop down here, we just write to that pin number of 10 a value of high, and then we wait for 300 milliseconds, and then write a value of low, and then wait for 300 milliseconds, and then just keep going around in a loop. And then when we exit, we just close that pin again. It's good practice to do that and free up the resources. So I'll .NET run that, and then I'll show you this again. I'll just zoom in a little bit more. And if everything works correctly, we should get a flashing LED. Now, what I've got to do this, I've got my phone and a little app called IP Webcam Pro. And that broadcasts the camera on the phone out on a web address, and you can dial into it. But what it means is it looks like that LED is flashing at a really irregular pattern. It isn't in real life, trust me. It's just that it's kind of jerky. If you look with my hand there moving, that's what's causing the irregular flash pattern. Nice and steady here. So good. So now we can drive outputs on the GPIO. Let's prove that we can read an input. So the next one is read a button. And I'll let that finish off doing what it's doing on there. Everything at the top of this file is exactly the same, but now we've got a button pin on 26, and you see that's where we connected that on our circuit. And then the next thing we're going to do down here is open that button pin as an input pull-up. Now on this circuit, we've got that button connected directly to a GPIO pin, and if you don't drag that in a particular direction, it'll just float, and you won't necessarily know what value you're going to read back from it. So you must make sure you pull that up or down. And it's important to pull that in a direction because otherwise it's going to float, but it's also important to know which way you pull it. Because I've pulled it up, when I press the button, it's going to make that input go low because I'm connecting the other side to ground. which is going to make this logic feel a bit funny, because when I read that button pin in, if it's false, if it's a 0, if it's not true, then I turn the LED on. So that kind of feels backwards, but it will make the circuit work properly. And if I don't press it, then it goes low. And I just sit there in that loop. And again, I can close the pin at the end. So let's just make sure that runs. And then the first thing we'll see is that LED will turn itself off. There we are. So LED is off. And I can press the button and now the LED will come on again. So that, I mean, the programming logic is a little bit backwards, but the circuit logic works there. So I quite like that. And I mean, essentially that is the demos at that point, because the next steps were to drive a robot arm and things like that. But this is a lightning talk and we've not got all that much time. So back to the slides again. There is this extra, by all means, just come off mute. If you've got a question, just intercede. It's fine. I don't mind. There's this extra load of code that somebody else has written here, which is fantastic. The IoT.Device.bindings, and if I can get rid of that sharing thing, that'll be good. There we go. And what it does is you import that NuGet package, and now you've got access to all these extra peripherals. So things like I/O expanders and temperature and humidity sensors, Explorer hats, Sense hats, which if you've never seen one before, if it comes out on there, this is a Sense hat. And Tim Peake took 2 Raspberry Pis with these strapped on the top up to the space station when he went up there, and kids can write programs against this Sense hat in Python, as it happens, that run on the space station, and they get those results back. It's really cool. It's the AstroPi project, it's called. But what's cool about this board is it's got a bunch of displays, a bunch of LEDs as a display, a little joystick, temperature sensor, humidity sensor, gyroscope, magnetometer, and it's about 20 quid or something like that. And you plug it on your Pi and somebody's written some code to control it. So you've got this board you just plug in, you don't need to wire any sensors up. Onwards from that, there's also servo control, and that's great for driving things like the robot that I had on here. And heaps more. If you go to the GitHub repository, I've got a link for it at the end, then there's a list of about 30, 40 devices. It's well worth checking that out. So as far as links is concerned, I've got a blog post on how to do everything that I've explained today there. So if you go to that bit.ly, then you can run through that. If you want to find out a bit more about just C# 9 and .NET 5, then go ahead and hit that bit.ly up. Those 2 NuGet packages that I mentioned, so specifically the GPIO one, you can go and find that at that NuGet address there. And if you go to the GitHub address for that IoT device bindings, then you can list all of the devices. And there's demonstration code and everything in there. Onwards from that, I run Nuts IoT, and we've got a meetup next month. So if you want to learn some more, then come along to that. Terence Eden and Peter Shaw will be speaking at that. And if you want to become a bit more serious about IoT, then myself and are writing some courses towards the AZ220 IoT developer exam and Microsoft exam. I helped create the exam, and now I'm helping to create the Pluralsight content. So you can imagine it's relatively well aligned. And if you want to get in touch with me, then there's about 1 million ways, but Twitter @Pete_codes is definitely the best way. And the slides will be available. In fact, they are available at that bit.ly at the bottom of the screen. And that is about it. I don't know what my timing was like there, but
it was spot on, Peter, because I actually told you you'd been reduced to 10 minutes. That's completely my fault. So apologies there.
Thanks, Pete. Have we got time? Have we got time to see the robot arm?
if you say we've got time, we absolutely have, and I can demo that quite quickly. So if I go back, so I should still be sharing. If I go back to here, so what I won't do is do the interactivity, the Blazor Signal R version, because that takes a little bit more time. But I can do the demo code that makes it do a little dance.
Cool.
So actually, press the wrong branch. One sec. I want to do move servos. Let that switch that branch. One sec. And I'll quickly explain what that does. Because this code is sitting on the part. Oh, there we are. I'm force checking. I don't know why it's come. I don't usually go that direction. One sec. Let me go back to the start. Oh no, it's going to do it. It's done it. Right. So we've brought in PWM pulse width modulation. That's about like the width of a pulse means how far these little motors will go. and then you create a couple of those PWM channels, and then you use that device bindings to be able to import PWM into that and drive a servo. And then all I'm doing here is just exercising the servos on there. So if I run that, assuming I've not broken it by switching branches the wrong direction. And my batteries are a little bit low as well. Oh, there we are. So you should see that was the pincer, and then that's the Raspberry. Batteries are a bit low.
That's really cool.
And that's the sort of stuff you can do. And actually, the code is quite easy for that. There's you saw that there's not much to it there.
Just out of interest, have you 3D printed that robot arm?
Yes, indeed, I have. And the version, if you go, you'll find my talk on there about the robot arm on YouTube. So go and check that out. But actually, in the GitHub repo, my mate Cliff Aegis, who's awesome at BA bloody pilot, and not only is he a pilot, he's also a great IoT guy. Him and his son have created some better 3D printed parts. This is quite complicated to put together. This
he's actually done a talk.
We've had him along to Leeds Sharp.
Yes, Handy is probably what he was talking about, or it'll have been his flight sim that he created.
Yeah.
But yeah, this takes about 4 hours to print. This particular robot arm does,
Wow.
but the version he had takes 2 hours and takes about 20 minutes to assemble. It's awesome piece of kit. Something to bear in mind though, the Raspberry Pi's only got 2 hardware PWM channels, and the .NET code relies on hardware PWM. There is a software PWM in there, but it's naff and doesn't work very well. So what you'd probably end up doing is buying an I2C PWM board and doing it separately. But I wanted to do it this way because that library of code, the IoT device bindings, is fantastic. So it's well worth going and checking that out. And yeah, go and check the big talk out of this. It's fun. There's some bloopers at the end, which are quite cool. So yeah, go and check
Very
that out.
cool.
And yeah, thanks for
you,
that.
Pete.
No worries. I can't find that thing I dragged off the screen now to unshare my screen.
I'll unshare you.
Yeah, good on you.
And remember, I'll put questions in the comments, and anything you want burning questions, ask for Peter and keep the conversation going.
Yeah, the chat's very.
Oh, I see.
very
There's a few bits in there. Thank you.
I'm gonna take over. Okay, can you see my slides? Yes. Okay, cool. Right. So I've got a Raspberry Pi for Christmas, and it's one of my side projects that I just kind of had a bit of fun with and kept going with it. And then I thought, oh, I can make a talk out of this. It'd be quite interesting. My name is John Staveley. I'm an organizer at Leeds Sharp and .NET contractor in the Leeds area. And I'm an avid bird watcher. I've been known to go bird watching at least 4 or 5 times a year. And there's birds that come into our garden and go to the feeders, but I never see them. So I thought, well, I've got this Raspberry Pi here. Maybe I can create something or take pictures and find out what's appearing in the garden. But we also have a lot of cats. So I thought, well, can I filter out the cats in some way? So what I built was this. So there's a Raspberry Pi, and it's got a camera attached to it and a motion sensor. So you can see on here, this is the camera and this is the motion sensor. So this is an infrared motion sensor. So if a frog goes past, it doesn't set it off, but if a cat or a bird goes past, it will set it off. So there's some code on the Pi written in .NET 5. It takes a picture and uploads it to Azure IoT Hub, which then stores it in blob storage. And then there's an Azure function to process that's triggered by a new blob arriving the blob storage, and that pipes it through to cognitive services, which does image recognition on the image, and then sends a message back to Azure IoT Hub for reasons why I'll tell you later. So Pete's already done the introduction to Raspberry Pi. I thought it was a hobbyist device, but there are some serious industrial applications built with this, and Raspberry Pi 4B is just the latest iteration in that. It's got Wi-Fi on board and the camera slots. This is the camera port here. It's got 2 HDMI ports, USB 2, USB 3, Ethernet, Wi-Fi on board, USB-C for power, and all the GPIO. So this is what my Pi in a box looks like. This is the infrared motion sensor, camera on top. It's got a hardened case and some scaffolding just to sort of hold it all together so it doesn't fall off the bed table. Of course, yeah, it gets a bit expensive, £110 all in, but it's not the only use I'm going to have for this. I'm going to extend it and use it for also other things. And you can buy it from Piperoni, which is a really good shop. So what I use, so it's Linux, it's 32-bit, but it's running this is all .NET 5 code that it's running on. It's virtually identical. Well, it is identical to, you know, .NET. If you've done any .NET Core or even full-fat .NET, it's very, very similar. Use VNC and to get onto the desktop, and that's what the desktop looks like. And SFTP. Once you build your assets, then push those binaries over to the Pi, and you can run them there. And you can run Python natively as well. Here I've got Visual Studio Code installed in it, so I can actually program on the Pi if I wanted to. So this is the code that's on the Pi. So I set up a bit of configuration. This is my connection string to the IoT Hub. And then I set a custom method on that, so the IoT Hub can call into the Pi cat alert when it's detected a cat. So I'm just setting up one pin, which is just the infrared sensor, and then it does an infinite loop. Says and if there's anything sensing motion in it, then it captures an image. So the Azure setup is really pretty basic. You can set all this up on the free tiers. You just need to, when you've registered the IoT Hub, register the device on it, and you get a sort of personalized connection string for your Pi, which then sits on the Pi. The blob storage is just 2 containers, and again, you need the connection strings for that. And then the FunctionApp, once you've set it up in Azure, get the deployment code, so you can then take your Visual Studio Code and deploy straight to the function. Cognitive services, you get 8,000 free impressions per month, so that's more than enough for the number of birds that visit my garden, and you just need to get the secret and the endpoint from that and put that inside the Azure function code. So what happens in the Azure function? So a blob comes in and triggers the Azure function. It then calls into cognitive services and says, hello, here's something for you to analyze. And it tells cognitive services what kind of things outputs it wants to look for, that like object identification and tag identification, that kind of thing. And then it comes back, does image classification, and then sends all that information back to the Azure function and say, this is what I found. You know, there's a cat at this pixel and this pixel on the picture, and or anything else. And then it has, bearing in mind what it finds, whether it's a cat, a bird, or something else, it then stores it appropriately, so I can only look at images that are interesting to me.
John.
And then, if necessary, sends the feedback to the Raspberry Pi.
John.
Hello.
Hey, can I just ask, have you managed to take any embarrassing images of neighbors running around naked in your garden or something like that?
Not yet. I've got a cat drinking from the pond.
Okay, carry on.
So going through the image analysis code, so this is the Azure function. So it's got a blob trigger on it, and it sets up a connection to the cognitive services, and it says I'm looking for these features. So I want to get the categories, tags, main colors, any objects that you've identified within the picture, any faces, and the image type. You can also test for other things like brands or indecent images, kind of things that cognitive services can do. Then you fire it off and say, you know, go and analyze it. So there's just a bit of code that says, did you find a bird in it? Did you find a cat? No, I don't. And then post a summary to the Azure function, and then change the file name and save it to blob storage in the appropriate place. And if there is a cat, send a message to the device so the device knows there's a cat, it's looking at a cat. Very important, more about that later. So cognitive services gives you something like this. So it says, if I fired this at it, go description, ducks on the pond, a series of tags, tree, outdoor, grass, water, lake, duck, animal, bird, goose, pond. It doesn't say what kind of duck or what kind of bird often, but you know, it gives you some good indications of what's there. And it says there's a bird at X coordinate, Y coordinate of width and height. So you can actually draw a box around that if you wanted to, and tells you the dominant colors. And for each of those, it'll give you a confidence interval of 0 to 1, how confident it is. Okay, so let's say there's a duck lands on a pond. It would then trigger the motion sensor, and then the Pi would then report it's taken a picture and the size of it. And then the function would go, summary, taking this picture, and the description, a duck in a pool with confidence 47.6%. I mean, it's not very confident, but it's actually right and accurate pretty much most of the time. So yes, has bird true, has cat false. So let's say there's a cat wanders in front of you here. So it's taken a picture, cat's move about lock, so it's taken a few more pictures, then processes that over to the Azure function. It's taken a picture, a white cat sitting on a rock with confidence 46%. Again, not very confident, but very accurate. Has bird no, has cat true. Then it makes a call to the IoT Hub, direct name cat alert. So it then sends a message back to the Pi saying, you know, you're looking at a cat, you might want to do something about it. So I think it's quite an interesting project. A lot of this code is literally just the get started of various parts, all just stitched together. So the get started of cognitive services and some basic Raspberry Pi stuff and the Azure function stuff. But if you stitch it all together, you've actually got a fully functioning app that could do something useful. And I thought it was quite interesting. So some things I'd like to do is improve the image recognition. So it's like, oh, you're looking at a sparrow or robin, a blue tit, a blackbird, that kind of thing. You could also remove the need to call into the internet and run it in the wild somewhere. And you can do that by having cognitive services running on a container on the Pi, because you can actually have containers on the Pi if you've giving it enough juice. Or you can have, there's an image recognition hat developed by Google, which you can sit on the Pi, so that negates the need to call out to the internet. One interesting thing I thought I could do with it is do infrared detection working at night, see what's strolling through the garden at night. And then because the Raspberry Pi knows that it's looking at cat, you might want to put in some small amount of cat deterrent, because as we know, cats kill birds and that's bad for wildlife. So, and before anyone objects, that's a joke. Yeah, we won't do questions, but please take any questions in the comments.
Thanks, John. Great talk.
Any birds were saved during this presentation?
Well, I haven't attached the cat deterrent yet, but I'm going to think there's going to be lots of birds happy to be in my garden in the future.
Can I just say, isn't it amazing what Microsoft are offering on the Azure platform, that you can do all this for free?
Yeah, and just like, it was really easy to set up. I really encourage people to go and have a play with this stuff, because it's so powerful and it's so easy.
Once we listen to people like you, John.
Okay.
Kevin.
Kev.
Yeah, I'm rolling. So cool. My talk's testing like you're a human, and this came from like a little project what I was doing on the side for a running thing what I usually do. So for people who don't know, I run 2 .NET groups, one in York and one in Sheffield. So we usually run 2 events every month, but we try to cut it down so they're only an hour or less every session. I'm going to the next slide. So One of my little side projects was actually to create this map website to actually label park runs within the UK. And it got quite a lot of traction. And when I was at a DV event, somebody questioned, was mentioning actually they found some park runs near to the DV event, and they showed me this app, and it was actually my website. And I was like, that's cool. Other people are using it. I also got messaged by some people in Australia to ask if it could be extended to the Australia park runs. And I did that as well. And then it kind of grew from there for kind of other kind of bits and bobs. So it's all runs on Azure Functions as the API at the backend end, and it runs MongoDB. So if you know me, I love MongoDB. So it runs in a database of Mongo, and the front end's all in React. But it has quite a lot of data behind it, to be fair. And all this data comes from the scraping their current website. So I can get things like the title of the park run, the location, to the long of where it is at. And I've also got information about kind of the terrain and if it's like disability friendly, if you can use buggies and run around with buggies, if they've got toilets, if you can take your dog, and all sorts of information, which I kind of collect as well. And you can drill down into that as well and get these pages of the individual park runs and kind of see a bit more information. So the kind of scraping the data side is where it came quite, I suppose it was easy to kind of think about, but it came quite complex to start with. So the pages look like this, and I scraped like these parts of, let me get a pointer. So these parts of the data like here and here to get the course details and the course descriptions. And this is one of the other pages, and it's pretty much exactly the same. So the course and course descriptions. And even that Irish one is the kind of the same thing. And the URLs are usually the domain name, the actual parkrun name, and the course. So to scrape these, I kind of just did a GET request to the HPS website with the domain, the parkrun name, and the course. And I got the whole block of like HTML, and then just use CSS selected on top of it. And to get the course information, I just went and select the ID of main with the CSS selector of the class of course left with the first child. And then for the description, I did exactly the same, except for get the paragraph tag instead for the course right. So this is kind of what they look like. So the CSS selectors would select this bit up here on the left-hand side and this bit down here on the right-hand side. And I assume that would work pretty well for kind of all the pages because everybody uses the templates, their nice websites out, and every single page would be filled in exactly the same. But this was like really brittle, and it only worked for like probably less than 30% of the pages. So when I went back and kind of after dumping all the data for all these pages, because there's thousands of them, I figured out like certain things like this wasn't a p tag on all of them. It was a div tag on some of them. And some of them had random p tags in the middle of like kind of the course description and the actual description itself. So when I was actually explicitly kind of trying to parse this explicitly with like CSS selected, it just didn't work. But one thing, they all look the same. So to me, when I was reading the page, they all look the same. And it is built on top of a WordPress website. And you can tell by looking at the markup, they've copied and pasted all the pages and they've all kind of diverged in their own little tiny ways. So it makes them really hard to parse quite explicitly. So if we kind of look at this as like a person using the website, we'd probably scan that. If I was to say like, what is the course description? I wouldn't go read all the page. I'd scan the titles. So I'd go look at the course, and then I'd go look at course safety. Then I'd go look at course map, and then be looking at course description. I'm like, oh, course description. And then I'd read down onto the course description itself. So I kind of programmatically writ that to kind of scan the actual titles and then read the next block of text for whatever the title was. And that worked pretty well, to be fair. And it's not broken yet, it's still running now. But one thing it kind of fell of was it only worked for English pages. So this is running Italy, France, Germany, loads of other countries. So this is one of the German pages. Obviously, all the titles are kind of not the same anymore. They're not in English. And this is in Russian, I think. I don't know, I can't remember. Whatever language it is, I don't know the language. So I ended up making a language map based on all the kind of description, the different types of headers, what I want to kind of skip down, and their different domains for that language, what there is in. So it's even got like Japanese down here as well. So I can parse Japanese pages as well. And this was great, to be fair. And it worked for like every single language, and it's not broken yet. So this is really good. And you're probably thinking, what has this got to do with testing? He's just talking about like kind of scraping some websites to create some other website from it. And the reason why is people use XPath and CSS selectors really explicitly in their tests. And the idea is that we should test the behavior like we're interacting like a human in our test suite. And tests should only fail when we've broken behavior, not if we move around some different p tags on the page or change things to spans. The behavior has not changed the page. So why should we kind of fail all our tests? It just makes them really brittle. And also our code should explain kind of how we're kind of interacting with the page as well for our tests. So they're nice and easy to read. And just parsing using CSS selectors or XPath selectors, it just makes it really hard to understand. And if you've ever tried to diagnose a test suite by just XPath and CSS selectors, it's like impossible, especially when you've got like hundreds and hundreds of them. And if you look at like one of the, any really example where you get on the internet of how to use Selenium, I Googled kind of examples of Selenium in C#. And this is the first page what I came to, and it gave me this bit of code, and it says, it's pretty simple to read. You create a Chrome driver, you go to this website, and then you go find this element, which is based on this select XPath. So we're going to find the ID, which is the an element in the page, which has an ID of RT header. And then we're going to select the third div with the div inside it with a unordered list with the third list item and go get the A tag of it. And then it's going to start in a variable and we're going to click it and then we're going to close, and that's all we're going to do. And then that's really simple to read, but you don't really know what it's going on about really, I suppose. And to make it worse, this is actually the page what they give you an example to run it on. So when I gave this talk, I actually asked like where in this page does that click? So based on this XPath selector, and you're looking at this page, you'd have no idea where it's going to click on this page. You'd be like, what link? I'm trying to kind of compute the code, what I've just read, onto this page to kind of understand where I'm going to click, and I've got no idea. When I'm looking at it, when I was trying to figure it out myself, I was just like, I have no idea without actually running the code. So I actually downloaded one of the plugins, an XPath like kind of query for Chrome, and it actually selects this one here. And I literally copied and pasted the actual query into there as well. So it's kind of, for you to kind of debug these kind of tests, they're like kind of impossible to debug really. So kind of thinking back, what would be better based on our kind of scraping examples? It'd be much better if we could just say, go click the testing link, because pretty much what that page is doing, that bit of code. And it's not going to be brittle because it actually says what it's doing and it's really nice and easy to understand. So we just say, click the link and give it the bit of text what it's going to click. And what also we probably want to do is be able to fill in different types of films. So we want to be able to say, fill in my name with Kevin Smith, fill in my phone number with my phone number, go select car, check baby seat, check the wheelchair access, click the submit button, which is submit booking. So that we'd go down this kind of form and do all these kind of operations for us. And we want to be able to describe this in code in a fairly kind of maintainable and easy to read way. So if you look at some C#, I probably think it should look like this. So we'd have browser fill in name with Kevin Smith and browser.fill in phone number with my phone number and etc. To even the points with like browser.select tax office from pickup place. And that'd be really nice to have that. And you're probably thinking, is that really valid C#? And it actually comes from a library called Koipu. And this uses like a way to match elements on the page based on kind of different kind of ways you kind of build pages. So these are the kind of ways that actually tries to match them. So based on like kind of different labels, it matches the text on the label and goes and finds the element for it. You can also match just text in the page. You can match titles and alt tags on things like images and links. You can match directly on IDs, the names, placeholders. So if you have some placeholder text in the actual text box, you can find that, and also radio button values. So all that kind of code there works perfectly fine when you run it against Koipu. And that's pretty much the takeaway for my kind of talk. That we should be starting to write tests as if you're interacting with the page and actually testing the behavior of the application, not just by creating these brittle tests, which actually are trying to use CSS selectors and XPath selectors to find things. And you don't have to use like Koipu. That's just a kind of one example, and it's kind of pretty relevant for this group because it's a .NET group. So Koipu is a .NET library. It's kind of copied from Capybara, I think it is, which is from Ruby. And it allows you to build like your own kind of definition language around your application as well. So you can wrap these up into a more kind of solid thing, which actually makes sense for your application. So even if you're not using a library like Koipu, try to kind of abstract away kind of the nitty gritty details of kind of how things are actually being selected and clicked on the page and wrap them kind of up. And that's the end of my talk. I usually have demos, but I would just cut them short. So I don't know how quick I was. I feel like quick. Oh, 11 minutes, 49 seconds. That's pretty good.
Well done, Kevin. Thank you very much. Brilliant. As usual, any questions for Kevin, please put them in the chat. Who do we have next? Is it Gopal?
Is it me or John?
Me was next,
Yeah.
but I don't mind.
Okay.
Yeah, I think John
No, I
was.
don't mind, John. You can go on.
John, okay.
Okay, so let me just share my screen. There you go. Hopefully you can see that now. So thank you. My name's John, and during the day I'm a software engineer, an architect at a gym company. But today I'm going to talk about device code OAuth flow, which is particularly useful in IoT. If you've got any questions, just put them in the chat or interrupt me, and I can pick those up. All the code for this is on GitHub. It's also on my blog, and I'll put the link at the end. So I had a bit of a side project, and I was running my app on Raspberry Pi, and I needed to read some of the information from my Microsoft account. But what I didn't want to do was embed my username and password in the config file. Various reasons, it just didn't feel like the right thing to do. And I'd use OAuth in many other places. But it was about how I could access the OAuth flow. Normally you do that through a web browser. It's not really possible in this scenario because I didn't have a screen attached. And that's what this talk kind of comes down to, about how we solve that problem. So first of all, I'm just going to cover what is OAuth, just a bit of a recap. Most of you have probably used it, definitely as a consumer, if not in code. So we'll do a recap. Then we'll look at the different OAuth flows. And device flow is one of many flows that you can use with OAuth. Then we'll do a deeper dive on how it actually works, going back and forth between the different people involved. And then hopefully we'll have some time just to do a very quick demo. So what is OAuth? Well, OAuth is a way of accessing resources without needing to manage the username or password that an end user might give you. So before we had OAuth, we'd use basic authentication. You'd take the username and password, you'd base64 encode it, and pass it across in a HTTP header with every single request. But the problem is, when you want to access third-party data, nobody's really going to put their Facebook username and password into your app in order for you then to pass that across to get access to their Facebook data or your Microsoft account in this scenario. And that's where OAuth really comes in. With OAuth, you get back a token through one of the many flows that's been authorized by the end user, and you use that token in order to get access to the information. So how do we get this token? Well, the most common way is using a flow called authorization code flow, which is browser-based. So in your website, you want to get how many friends someone has in Facebook. You implement this OAuth flow, and then as people interact with your website, they're taken off to Facebook and it's on the Facebook website that they can enter their username and password. Then they're redirected back to your website, and you've then got a token that lasts until it's revoked or expires, but you can then use that to access the data. And this is a really powerful flow, and it's used by most systems that want to grab data, but it only works if you have a web browser. And when we start talking about IoT devices, maybe it's a Raspberry Pi that's sat out in the field, or maybe it's an embedded device. You don't have access to a browser. So we need to solve this in another way. We could use a second flow called client credentials flow, and this is designed for machine-to-machine communication. But it does rely on both of the machines being highly secure and being able to hold a secret. And when we start talking about IoT, then these devices are out in customers' hands and aren't necessarily truly secure. We could fall back and rely on a password grant flow, embed our username and password in a config file. You then pass that username and password over to the server and get an OAuth token back. And then you can use the OAuth token from that point forward. But it kind of defeats the point about what we're trying to do. You've got to then manage the username and password of a third-party system in your application. It's actually marked as legacy and is advised not to use, although many systems still do use it. For this reason, it kind of defeats the point of not managing passwords and usernames. So that brings us on to device flow. Now, device flow solves these problems. It's actually designed for browserless and input constrained devices, which fits really nicely with IoT. If we think about something like a TV, that falls in the category of input constrained devices. I had a really bad experience in an Xbox game once. I wanted to play the game, and it was a preview version of the game, and it actually chucked me out of the game and threw me into the Edge browser on the Xbox. And this is an awful experience. If any of you ever tried to type using the on-screen keyboard, it just doesn't really work. So yeah, this is definitely an input constrained device, and a browser flow is not going to work for us. Some apps get around this by designing their own screen in which you can type in your username and password in a much more friendly way. But that's fine if it's your system and your accounts. I'm happy to put my Netflix password into my Netflix app, but you're not going to do it if it's an app that's accessing third-party data. So this is where device code flow solves this problem. It allows your app to run on one device, and then for your end user to use a second device to authorize it. And then your primary device will go back and have that OAuth token available to it. And you might have seen this in many places. If you sign into the iPlayer on a TV, or Plex, or lots of different things will show you a URL and get you to enter the code. We obviously don't all write apps for TVs, but this is very much applicable to things like the Raspberry Pi that we've seen already. You might have a small screen like this that's just got 2 lines. It's not going to support a full browser, but it is going to support a URL and a code for you to enter. Alternatively, it also works well if you've just got a terminal. This is the Azure Cloud Shell, and you can see here it's prompted me to go off to a web browser and enter the code to authorize it to access my Azure account. But it would also work if you were SSHing into a device, or you could even use the browser flow and put the code and the URL into a log that you could access just once in order to get that. So let's take a deeper dive into how it actually works. So your app's running on the device, and it goes off to the third party and says, I want to initiate the flow. The first thing it does is come back with a URL and the code to enter. Your app will then continue to poll the third party saying, is there an OAuth token available for me? And most of the time it's going to come back and say, no, it's in pending state. We're still waiting, hasn't been authorized yet. Meanwhile, your end user has got their mobile phone out, they've typed in the URL, they visited the website and typed in the code. Once that's been done, your polling that you're doing from your app will come back and go, yeah, here's an OAuth token. And from that point forward, you're all good. You can use that OAuth token to access any of the resources on that API. So if we just take a look now at a live demo. So we've got here is Postman, and these are just API calls. There are client libraries that will wrap all this up for you really nicely, but you can just do it with REST if you want to. So our first call this is using the Microsoft Graph API, and I've already registered an application in Azure. The instructions for that are in the GitHub repo and on the blog post. But for time's sake, I'll just use an app that I've already configured. So we create our first call, we click send. That comes back with the device code, which we'll just copy. The user code, a device code which we'll need later inside our code to make further API calls, and the URL. It also gives an interval to poll, which we'll see in a minute. And finally, a nice friendly message that you can just show if you want to. So we'll next look at the polling call. So this uses some of the information from the first call. So you can see there the device code, so it knows what it's checking for, and it uses your client ID and tenant the same as the first call. And when we click send, it says authorization pending. So that's explaining that so far, every time I make that call, we haven't actually been authorized yet. So if we switch over, we've gone to the URL that was requested, paste in the code, and click next. At this point, I'll be asked to log in if I've not logged in. So I'll just quickly log in. And that's the end of the interaction on the Microsoft website. And I can flick now back to the Postman. And on my polling call, if I do that again, I will now get an OAuth token. I also get a refresh token. So once it expires, I can use the refresh token to get a new token. And we can use that token here just to do a simple me request on the Microsoft Graph API. So that's really simple how we do it. We make the initial call, we poll for it. Once it's got, we can then use the token and say it supports refresh tokens. This Postman collection is also on the GitHub as well. So if we get now back to the presentation, so what we saw there was accessing the Microsoft Graph API, but loads of APIs support this. ID Server also supports it, so you can use it for your own applications. So even if you don't need third-party data, but you want to make a nice seamless login experience, or you've got a scenario that would benefit from it, you can use ID Server. ZeroAuth also supports it if you're using them, using that service, and yeah, most other APIs as well. So all of the code samples, as I said, are here on the GitHub. I've also today posted a blog post which summarizes this talk with screenshots and various other bits as well. Okay, that was it.
Thanks, John.
Fantastic, John. Thank you.
John, I wish you could go to the visit the BritBox team and give your talk, because they have an awful experience for logging in. It made me think. Your talk made me think about that when I tried. I was, trying to log in, and I was thinking, why don't they have this?
Yeah, more and more systems are using it. I've seen over the last kind of year or so. I've seen more and more do it. It's just so much easier than having to type it in on a TV remote or on a Yeah, on a gaming console remote.
The worst thing is, right, if you're using LastPass and you've got a 64 character random generated password and you have to type this in on a TV remote, it's terrible.
Great, as always, questions in the chat. If there's anything, John, specific you want to ask John about, if you could have Gopal next. Gopal's calling in from Bangalore, India. I think it's past midnight there, so
Yeah.
just a round of applause for making it. Well done.
Thank you. And I'm glad that I'm still awake. So I'll try to stay awake for the next 10 minutes as I talk. Okay, thanks for having me. So good evening, everyone. So this session is, so my name is Gopal, and John said I'm from Bangalore, India. I work as a software manager in a company called Crocon Detection Instruments. So we have head office in near Oxford in the UK. So we run a software development team here, and we work on a number of web applications, desktop and mobiles, mostly using the .NET technologies and Azure. So this session, I'm just going to talk about Active Directory B2C. Now, compared to the bird watching and the robotic arms, so this session is going to be much less interesting because I just have a PowerPoint presentation and a few slides. There is no demo because I think we are running short of time. So I'll just give a very brief introduction to what it is and why do we need it, and what are the advantages and how do we configure it. So let me just get, so I hope you can see the screen. Right, so first of all, before looking at what is Active Directory B2C, we would just go through a few points about why do we need this. So basically the question is, why do we need an external identity for our applications? Because it, like when I was working on a web application, we were storing a lot of our user information in our own database. So username and the password, though it in a hashed form and all that stuff, but still we were maintaining that. And then I was looking at some alternatives to make it more secure, and I came across these external identity solutions. So the answer to this question is, why do we need this external identity? The answer is the same as why don't you write your own encryption algorithm? Because it is really hard, and mainly it is risky to store the user's information on our own and to keep it secure because we are storing all the user's identity and password. And if you go to the advanced applications, you store even the credit card details and all that stuff if you want. So there exists actually a lot of services in the market which abstract all this complexity behind identity management and risk in maintaining all this stuff. And this Active Directory B2C, it's one of those services. So it is so if we see it in nutshell, it's actually we can call it as an identity as a service in the Azure cloud. So it's a fully managed service in the Azure cloud, and it is focused on applications which are consumer oriented, like end customer oriented, rather than your internal applications running within your enterprise. And what it means is that your users can use their existing social accounts such as Google or Facebook or Twitter, GitHub, and so on to log into your applications. So you don't have to have a new password and new username and all that stuff. So they get a kind of single sign-on experience using their existing accounts. And that's where the B2C comes in this. So, and you can use it in the web applications as well as JavaScript, SPAs, and even desktop or mobile applications with the same user experience across all these applications. So you can maintain a consistent user interface across all these applications, because all the user interface is actually served from the Active Directory B2C. You don't have to write all the HTML, or if you are in desktop, you don't have to write the XAML and all that stuff. All right, so that's the basic about this AD-B2C. Now, I don't have a demo as such. I do have it running. So towards the end of this presentation, I can just show a couple of one web applications that I have. However, this is the screenshot from a web application that I have got. And if you can see it, so we can have the user sign up with email address and password. It is called something as a local account, and they can sign up with a new email address and password. They can also sign up here. So sorry, they can also sign up for a new application. So it's a self sign up. That means your IT administrator doesn't have to do anything to maintain the user accounts, and so users can do the self sign up. Also maintaining, sorry, the for if the users forget the passwords and all that, that's also being taken care of here. And the interesting thing is that this one, that they can sign in with their social accounts. So in this particular example, I had configured it for Twitter and GitHub and Microsoft account, but there are still multiple choices to configure multiple different social identities as well. So that's a basic screenshot for, and it's called as a sign in or sign up policy. That means, so policy or workflow, that means it's a user experience. So your users can sign up or sign into your application. And then once they sign in into your application, you can even do, they can edit their own profile, or they can reset their own password, and of course log out from the application. And so that's the basic one, but there are a number of advanced use cases possible with this solution. So you can have your, if you are running some web APIs in the backend and you want access tokens to access those web APIs from your web application or your front-end desktop application, you can get these access tokens. Because, so one thing I forgot to mention here was that the Active Directory B2C is actually a OAuth 2 providers. It supports these OAuth 2 flows and OpenID Connect protocol. So you get the ID tokens and access tokens, and you can use those tokens to access the web APIs. And you can even customize the user experience. So the HTML and the page that we saw, that's the default one that the Active Directory B2C serves, but you can completely customize that with your own branding or logo, and even the HTML, CSS, everything you can customize. And you can even offer these pages in multiple languages also. So it's not only English language specific. And then you can have custom user flows. So it supports these inbuilt user flows for sign in, sign up, and edit, but you can also customize these user flows. For example, you want to get notified when certain user signs up to your application. So their location or something that you want to maintain some kind of metrics inside your organization, then you can integrate your own REST APIs during these user flows. So that's an interesting actually option. You can also add customized identity providers. So there are typical standard identity providers. I think there are quite a good choices like the Google and GitHub and all those I mentioned. But suppose your customer is using something like Auth0 or maybe Okta or something, that as long as they are providing the OIDC, OpenID Connect flow, you can add them as custom identity providers. That means your end users can still keep using their existing accounts. They don't have to create a new account on your system. They can use their existing accounts and get a clean single sign-on experience with this. And finally, Microsoft provides the Graph APIs to manage the users. So you can have completely your own web application or whatever application to manage the users, such as add users or edit users. You can even prevent the users from self signing up if you don't want to do that, but you can do that all that on your own. So suppose you want your admin to do that. So that's provided by the Graph API. So yeah, these are the advanced use cases scenarios, and this is how Active Directory B2C, AD-B2C, that looks like in the Azure portal. So this, if you see, this is the app registrations pane. So I don't have all the screenshots right now. So the app registrations means it represents your application inside the AD-B2C, and then there is this company branding, where you can provide your own logos and path to your HTML if you want to customize that. Then the identity providers is the one where you actually configure these different social identity providers. and it's all completely optional. And the other main thing is the user flows, where you actually create your sign in, sign up flows and edit profile and reset password flows. So these user flows actually are common to all the applications. That means you create multiple applications, but still you can use the same sign in flow. That means you still offer the same user experience across all your applications. And there are quite a number of features in the preview stage, like the authentication methods, where I think they are planning to do, it's in preview already, that you can have the passwordless authentication. So you just have some SMS code, or using the authenticator app, you log into your application. And so these are the main things. And also you can see all the users here, and then you can add certain users to different roles in your applications. You can even do password reset or edit the user directly from here as an admin as well. So this ADB2C is actually quite a evolving product. So I think there are a lot of preview features, and still there are a lot of, the documentation is little complex. It's spread over number of pages and number of samples actually. So if this is interesting, these are a few broad steps to get started with ADB2C. So basically you need to have a valid Azure subscription first of all, and you create a ADB2C tenant inside the subscription. So tenant means actually it's a container which holds your applications and these different user flows, identity providers and everything together. And once you create the tenant, inside that tenant you register your app, and the app is actually it's a representation of your actual app from the ADB2C viewpoint. And then you create the required user flows. So as I said, they're optional. Like you suppose you want to just provide sign in and not sign up, you can do that separately. And let's say that you don't want the users to edit their profile or something, that also you can control from here. So you create all these user flows, and then optionally you can provide a social identity connections. So you need to go to those websites. Like for example, you want to provide a Twitter as social identity provider, you go to Twitter developer website and then create an app there, and you get API keys and API secret, and then put it back into the ADB2C. That is how it connects to the
Have you finished, Gopal?
Or is he frozen?
Have we lost him?
I think we lost him.
Cinderella went past midnight and
he's turned into a glass shoe.
Yes.
Oh, that's a shame.
That looks really, really interesting, really powerful, and yeah, I can see how that could be useful rather than having to write it yourself again.
Very useful, and I'm suspecting a lot cheaper than Auth0 or Okta.
Yeah. Simon, do you want to get set up?
Sure.
Simon works with Matt at Tronic, is a new dev and a new speaker. We need new speakers. If you have an idea for a talk, please see me, or Matt, or Peter, or Kevin. We're nice people, and we can discuss an idea with you. Oh, Gopal's back.
Yeah, sorry, my internet got disconnected for a moment. Sorry about that. So it's just the last slide, so I'll just be finishing in a couple of minutes. So can you still see the screen?
No, you need to share again.
Oh, sorry, 1 second. Where is it? Right. Okay. So I think you can see it now. Yeah. So, right. I think I was almost towards the end of this. That yeah, you just provide the application again with the ADB2C endpoints, and then you run your app and just call the login methods, either using the login pop-up or redirect, and then kind of you're done. So that's these are the broad steps to get started with ADB2C. And finally, this is link for all the documentation that I found, and there is a very good plural site course if you are interested. And I on my blog also I have written a couple of blog posts about how to get started with this. And of course, Microsoft has got a number of different pages for the documentation and the code samples and all that. So that's it. That I just wanted to cover that. And there is a demo, but I think we are still running short of time. So demo is nothing, it's just same screenshot. So I'll just skip that. So I think I might have missed the chat. So if there are any comments or questions, I'm still available.
Yes, I was just saying it looked really, really powerful and easy to set up and logically thought through. Okay. Thank you, Gopal, our first international speaker all the way from Bangalore.
Thanks, Gopal.
Thank you. Thanks for having me.
Any questions for Gopal, please put them in the chat. I can see there's some conversation already going on that. And if you could get Simon to do our last talk for the evening.
Right. Thank you.
Sure. So after a whole series of fascinating talks, mine may be somewhat less interesting. It's very much a step back, just fundamental domain-driven design, and the mediator pattern in particular. There we go. So this is the mediator pattern. Good night. No, I joke. So the mediator pattern was made famous by the 1994 book, Domain-Driven Design, which I'm sure an awful lot of you are familiar with. I'm sure an awful lot of you are also familiar with this pattern. If you are, do feel free to tune out a little bit. Essentially, it allows us to define an object that encapsulates how a set of objects interact. Or to put it a little more simply, it's an object that can just pass messages to other objects. Now, why would we want that? Surely it's more efficient just to talk to objects directly. Well, it's a way of loosely coupling those objects together and helps your projects, whatever you're working on, better comply with solid principles, especially the dependency inversion principle, which means, of course, when you come back to refactor your code, when it inevitably changes its use case, you'll only have to make changes in one class rather than multiples. As a little diagram of the pattern here, you have your colleague and your mediator and the concrete implementations of those of. The colleague tends to register with the mediator, and the mediator can then send out messages to the various colleagues. I've got a little thing here. So typically when we write code, you might, for example, create an object and tell that object to do a thing, but of course, instantly that couples those two objects together. So in the future, if we want to change our fake object there, it will break whatever we're doing in our other object. Whereas we come to the mediator pattern, and we have our colleague, which takes a mediator, and the mediator itself, which very simply just sends a message. And you'll see that that message contains itself and also the colleague that sent it. So it's a message that is addressed from the object that sends it. We've got a couple of concrete colleagues here. This is just very simply the concrete implementations of the colleague class. Very simply, they can send a message over to the mediator, and then they can handle a message that they receive. This could be anything. It could be, for example, a email service being told to dispatch an email to a client when an order has been made, or many, many, many other applications. The mediator itself, its concrete implementation, takes a series of the colleagues. Effectively, the colleagues register with the mediator as to receiving the messages. And then whenever the mediator receives a message, it simply sends that message out to everyone else who isn't the sender. Now, there's only two registered here, so it's a very, very, very simple implementation. And I apologize for this because this is about as simple as it possibly gets, but I didn't want to overcomplicate things. If we jump over to our program, we can see we create a new concrete mediator. We create a couple of the colleagues, and you'll see that we pass in the mediator to register the colleagues with the mediator. We can then send out some messages, and those can be then handled by whomever chooses to receive them. So the nice thing about this is you'll notice that the concrete colleague 1 and concrete colleague 2 contain no references to each other whatsoever. However, if we then quickly run the program, which the zoom bar is currently getting in the way of, quickly pull that down. Actually, let's just do an F5. You'll see that colleague 1, program back up. Colleague 1 has sent a message saying, "How are you?" You'll see that colleague 2 has received that message. And then colleague 2 has sent a message back saying, "I'm fine, thanks." And colleague 1 has received that message. But neither of them know that the other exists. They've just each chosen to subscribe to that mediator and have received the message because of that. They're totally uncoupled. This is really, really helpful, particularly when you're wanting to dispatch many, many, many actions at once. So right now, there's only, when colleague 2 sends out a message, there's only colleague 1 receiving it. However, there could be tens, hundreds, thousands, meaning that with one simple message, you can actually dispatch an awful lot of actions at once. So a good example of this might be an order surface in an e-commerce application, where when an order is received, it updates the stock, it sends out emails to the customer and also to the warehouse for the products to be dispatched. It's very, very similar to what you might see in the microservices applications, where you have a message bus, which you can send a message to, and whoever chooses to subscribe to it can then take those messages and act upon them accordingly. And if you were to come back and say in the future that you wanted to change how an action is handled, you can do that entirely without actually changing the class that is sending the message in the first place. That's about it, really. Very simple little pattern, but a very, very useful one in terms of decoupling your applications.
Simon?
All right, thank you.
Very good.
Brilliant. Well, that brings us to the end of our presentations. Can I thank everyone who's come to speak this evening? Apologies, everyone who got 10 minutes rather than 15. We'll try not to oversubscribe next time.
Yeah, great turnout, guys. Thanks for turning up.
Simon, can I say for saying that was your first talk, that was awesome. That was really good.
Yeah. Reminds us we always need to keep looking back at fundamentals like patterns and see where we can fit them in if they're appropriate.
I've never used that before, so it was great to see that. It was a nice way of decoupling, as you said. And I would have never known, like I said, that it was your first talk. Very confident. Good job.
That's it. Thank you.
It was second for me.
Oh, really? Well, I wouldn't have known that either.
Yeah.
Really good.
Recently, it was just one lightning talk I did at the, I think, mk.net. And that's how I came to know about the Leeds Sharp.
Oh,
Shai Digmal report. Yes.
Really good.
Thank you. Thank you.
Yeah, I don't know about you guys, Kevin, Pete, but Leeds Sharp's always been sort of like a practicing ground for speakers. Well, they maybe with ambitions to go on to likes of NDC or DDD.
Yep. Yeah, the more welcoming meetups that we can get just like that. And it's the same, I know, having been up to Kev's meetup, it's the friendly atmosphere and the supportive nature of the people that come along. And if you can nurture that, then we're going to get way more speakers, just like Gopal and Simon there. So yeah, definitely need that. Great job.
It'll be lovely when the meetups can begin and get in person, because I very much miss the coding dojos. That was actually my first introduction to Leeds Sharp before I ever even knew about Matt and Tronic. I attended one of the coding dojos, really enjoyed it, and then 3 months later, while I was teaching myself C#, got introduced to Matt by a recruiter and found a job with him.
Yeah. What a fantastic story! I love that.
Yeah. I mean, that's the benefit of sharing knowledge. It goes both ways. Obviously, we come along and we learn stuff, but you come along to share your information, and opportunities arise out of that just as easily, and improves confidence, gives you something to strive for. There's so many good reasons to speak at events like this if you can find nice ones.
Yeah, I always find like no matter what you got to say, somebody will learn something, to be fair, as well, which is great, because there's so much stuff to know about. Like you don't know everything in the world.
Yep.
And you definitely know something what somebody else doesn't know, and you just, even if it's like a simple pattern and things like that, like loads of people will just pick up on, like, learn loads of stuff.
Yeah, there needs to be more lightning talks at user groups, to be honest, and it's something that we don't do enough of. But they always go down so well because people don't have to prepare an hour-long talk, and it's an arduous process doing that. And then the problems with it going wrong part one.
Anyone can talk about something they're working on for 10 minutes. The time just goes, and all you got to do is fit a few slides together. It's not a huge undertaking.
Yeah, absolutely.
Great stuff, guys. Well, it's a wrap. Hopefully see you.
Fantastic.
Great to see everyone. Thank you for coming.
Thanks for all the speakers. Great talks.
Thank you.
Thanks for inviting
Good night.
us.
Everybody stay safe.
Bye.
Absolutely. Cheers.
Bye.
See you later.